Hello friends, Prerna this side from iNeuron. Welcome back to all of you. So in the previous session we have discussed till question number 15 of miscellaneous exercise of sequence and series. And today we are going to start from question number 16. So in this question it says if A into 1 by B plus 1 by C, comma B into 1 by C plus 1 by A, comma C into 1 by A plus 1 by B are in AP, prove that A, B, C are in AP. So the given condition is also in AP and you have to prove also in AP. So let's discuss what we have to do here. The question says A 1 by B, A 1 by B plus 1 by C, comma B 1 by C plus 1 by A, comma C 1 by A plus 1 by B are in AP. So for AP, what should we have? Second minus first is equal to third minus second. Okay. So here what we are going to do, twice of second term. We can say na A, B, C are in AP, then it can be written as 2B is equal to A plus C, isn't it? So I am doing the same thing. 2 times of second term is equal to first term plus third term. So it is 2B AC A plus C equal to A BC C plus B plus C AB B plus A. Okay. So what we have to do here, now we have to solve this equation. And we have to prove that A, B, C are in AP. So simply you have to prove that 2B is equal to A plus C. Okay, 2B is equal to A plus C. That's what you need to find. So let's solve this equation. So it is 2AB plus 2BC by AC is equal to AC plus AB by BC plus BC plus AC. Now what I am going to do, now I am taking LCM on right hand side. So it is ABC. So we have A square C plus A square B plus AB. So we have C, BC square plus AC square. And here we have 2AB plus 2BC. AC. Okay, now cross multiplying, it will give 2AB square plus 2B square C is equal to A square C plus A square B plus BC square plus AC square. That's it. Now see 2AB square we can write it AB square plus AB square plus B square C plus B square C is equal to A square C, A square B, BC square, AC square. Okay, so that's what we have. Now what need to find is 2B is equal to A plus C. So what we can do here, we can write B square A minus, where is B square A? B square A. Okay, so AB square minus A square B. This one and this one. Clear? I have taken A square B from right hand side to left hand side. Then I can write B square C b square c, okay, then we can write b square c minus a square c. Why I have done this? Let's see. If I'll take AB from these two, it will give B minus A. And if I'll take C, it will give B square minus A square. And we can write it AB, B minus A plus C, B minus A, B plus A. And if I'll take common B minus A, then I'll have AB plus C. I have taken B minus A, so I have CB plus CA. CB plus CA. Leave it here. Now on that side, what we have? C square A plus C square B. C square A. C square B. And rest are minus AB square minus B square C. Again, we have to arrange something like that. It will give similar type of common terms. Okay, similar type of common terms. So what we can do here, if I'll take C square, it is A plus B. If I'll take C square, it is A plus B. And from other things we have minus B square, then it will give again A minus B square, then it will give A plus C. That's not fine. So here it's not giving any common thing. So what I am doing, I am erasing this step and I am trying to get something similar to this part. So what I am doing here is I am taking C square B and B square C. So if I'll take BC common, then it will give C minus B from these two terms. And from the remaining terms, if I'll take A, then it is C square minus B square. That's it. Now the pattern is same. Now what we can do, we can write BC into C minus B plus A into C minus B, C plus B. In the next step, we are going to take common C minus B, C minus B. So we have BC plus AC plus AB. Now see, we have AB and AB, AC and AC, BC and BC. So we can cancel out these two brackets. So we have B minus A is equal to C minus B. Therefore A, B, C are in AP. That's what we needed to prove. So this is question number 16. So while solving, you can go through the pattern of one side so that you can assume or predict what should be the values in the right hand side. Okay, so this is question number 16. We are done with this question. Moving on to next question, that is question number 17. Question number 17 have many things. It says A, B, C, D are in GP. So when four terms are in GP, it means second by first is equal to third by second is equal to fourth by third. Now it is B square is equal to AC. Okay, from these two, C square is equal to BD from these two, and now we have BC is equal to AD. BC is equal to AD. Okay, so these three things are there given in the question. Now it says prove that a to the power n plus b to the power n, comma b to the power n plus c to the power n, comma c to the power n plus d to the power n are in GP. So this is what you need to prove. So according to question, we can say if three terms are in GP, that means square of second is equal to product of first and third, isn't it? So what we need to prove? What we need to prove here, square of second term b to the power n plus c to the power n, square of second term is equal to first term into third term. So this is what we need to prove. Okay, got it? So what I am going to do, I am solving this part to get this part. Okay, so a to the power n plus c to the power n whole square is a to the power n square plus b to the power n square, sorry, c, plus 2 into a to the power n, c to the power n. So this is the expansion. Okay, so it is, so we can write it is a to the power 2n plus c to the power 2n plus 2 into a to the power n, c to the power n. Got it? Okay, so here we have the value of b square, c square and bc. So I'm sorry, it should be b here, isn't it? So yeah, I'm sorry, it should be b, not a. Correct it, I'm sorry. So it is b here and again we have b here. So we have the value of b square, isn't it? So I can write it, the value of b square as ac to the power n, since it is b square to the power n, isn't it? So I can write b square as ac from equation 1. Similarly, what can I write here? bd to the power n plus a and c. So if a to the power n, it should be b and c again here, b. So bc is nothing but ad. So I am writing 2a and dn. Okay, that's all we have. That's all we have. So we have a to the power n, c to the power n plus b to the power n, d to the power n, and here we have a and dn, again a and dn. Okay, so a and cn plus b and dn, we have two things, same thing two times. So one can be changed into bc, so I am writing b and cn, and here we have a and dn. Now remember what we need to prove. We need to prove that this into this. So we should have a with this bracket and b with this bracket. So we should have a with c and d. A with c and a with d. So from these two terms, if I'll take an common, we have cn plus dn. And from the remaining two terms, if I'll take bn common, again I have cn plus dn. Okay, so we have an plus bn and cn plus dn. Proved. Clear? Okay, so I mistaken one place here. So it should be b. It should be b here, which I need to prove. I hope it is clear to all of you. Very easy question it was. Just a little things you need to remember, that I have to frame the equation in such a way so that I can get these things. I should get a with this bracket and b with this bracket. That's all. Okay, so this is question number 17. Moving on to next question, and it is question number 18. Question number 18 is, if a and b are root of x square minus 3x, so I am writing everything separately. This is the first equation whose roots are a and b, okay? And then it says that c and d are roots of this. So again we have x square minus 12x plus q equal to 0, and its roots are c and d. Okay, where a, b, c, d form a GP. It also says that a, b, c, d are in GP. That's all. So we have these three things, and the question says that you have to prove that q plus p is to q minus p is equal to 17 by 15. Okay. So first of all, we have learned that in quadratic equations, we have learned that sum of roots sum of roots is equal to, we have a and b, minus of this thing, isn't it? Minus b by a, if you remember. So it is minus b by a. So, and the product of root is c by a. So we have p here. So we can say that it gives, this part gives a plus b is equal to 3 and a into b is equal to p. Similarly, in this part we have c plus d is equal to minus of minus 12 by 1, or I can say c plus d is equal to 12 and c into d is equal to q. So we have nothing but c plus d is equal to 12 and c into d is equal to q. Is it clear? We know that in a quadratic equation, sum of root is equal to minus b by a. What is b here? You know that the question is always in the form of ax square plus bx plus c is equal to 0. So whatever is present, whatever be the coefficient of x, whatever be the coefficient of x, once again, whatever be the coefficient of x is the b, and whatever will be the coefficient of x square is a, according to our formula. Okay, so that's all. Then the question says that a, b, c, d are in gp. Okay, a, b, c, d are in gp. Now see, if they are in gp, let us consider that a is x, b is x into r, c is x into r square, I am multiplying r every time, and d is x into r cube. Okay, a is equal to x, b is equal to xr, c equal to xr square, and d equal to xr cube. Now using these things, can we find the value of pq, since we need to find the ratio of q plus p and q minus p? So we should know the value of p and q. So first of all, we need to find the value of a and b to get the value of p. Again, C and D to get the value of Q. So first of all, see what we have. A plus B is equal to 3. So I can write x plus xr is equal to 3. Now if I take x common, it is 1 plus r is equal to 3, and this is my first equation. Similarly, C plus D is equal to 12. So it is xr square plus xr cube is equal to 12, and if I'll take xr square common, we have 1 plus r equal to 12. This is equation number 2. Now if I'll divide 2 and 1, if I'll write 2 divided by 1, then it is xr square 1 plus r by x into 1 plus r is equal to 12 by 3. R square is equal to 4, so we have r is equal to 2 or minus 2. Now I am assuming one case only, that is r is equal to 2, and in similar manner you can find the things for r is equal to minus 2. So when r is 2, then equation 1 will give r is 2, then it is 2 plus 1 3, so x is equal to 1. Okay, x is equal to 1. Now can we find the value of a, b, c, d? Yes, the value of a will be x, the value of b will be x into r, that is 2, then x into r square, 1 into 2 square, that is 4, and x into r cube, 1 into 2 cube, that is 8. So I know the value of a, b, c, d now. Now what we need to find is p and q. What is p? P is nothing but a, b. So p is equal to a into b, that is 2, and q is equal to c into d. C into d, that is 4 into 8, 32. Okay, now what I am going to find? Q plus p by q minus p. So q plus p is 32 plus 2, and q minus p is 32 minus 2. So I have 34 by 30, and it is 17 by 15, and proved. Okay, the question was, two equations was there, and we need to find the value of p and q to get the ratio of p plus q by q minus p. Okay, so this is complete question number 18. Question number 18. Next, what we are going to do, question number 19. The ratio of the AM and GM of two positive numbers A and B is M is to N. Show that A is to B is equal to this. So this is the question, and let's see what it says. What is AM? The ratio of AM and GM. AM is A plus B by 2 divided by root AB, and question says it is M by N. Okay, M by N. Now A plus B by 2 root AB is equal to M by N. Okay, now I need to prove that A is to B is something. So simply I need to find the value of A and B. So it is nothing. Let's suppose that I am squaring it. So it is A plus B whole square is equal to 4AB is equal to M square by N square. Or simply I can say that A plus B whole square is equal to 4AB M square by N square. So if I'll write A plus B, then it is 2 M by N and a root AB, taking square root on both sides. Okay, though, so I don't need to do this. Okay, that's okay. Okay, I have done this, but you don't need to do this. It will give the same value. So let us suppose what should be the value of A minus B. So it should be A plus B whole square minus 4AB. We have discussed this thing before. So the value of A plus B whole square was, A plus B whole square is 4AB M square by N square minus 4AB. Okay, and if I'll take 4AB common, then I have M square by N square minus 1, or I can say M square minus N square by N square. Now if I want to find the value of A minus B only, A minus B only, so it will be 2 root AB root M square minus N square by N. Got it? Now what I am going to do, I am solving these two equations. The value of A plus B is here. The value of A minus B is here. Now if I add them, then it will be A plus B, A plus B plus A minus B. And on right hand side we have 2M by N root AB plus 2 root AB by N under root M square minus N square. This is. Now this will give 2A equal to something something. So it is 2A and I am taking common. It is 2A and I am taking common 2 root AB. So I have 2 root AB and by N also. So we have M plus under root M square minus N square. Clear? Clear or not? Okay, so the value of A is equal to root AB by N by M plus under root M square minus N square. Now I need to find the value of B to get the ratio of A and B. So if I'll put the value of A in any of the equations, so let us suppose I am putting it in equation 1, so it will give the value of B. B is equal to 2M by N root AB minus the value of A. So it is root AB by N and M plus under root M square minus N square. That's it. Okay, so it is B is equal to 2. I'll take root AB by N as common. That will be better. So root AB by N, if I'll take common, then I have 2M minus M. So I have M only, minus under root M square minus N square. Okay, now what I am going to do, I am dividing the value of A and B, since the question is asking about ratio of A and B. So A by B is equal to, the value of A is here under root AB by N, M plus under root M square minus N square, and at the denominator we have under root AB by N, M minus under root M square minus N square. See, we have the ratio which we need to prove. So this is question number 19. I hope it is clear to all of you. It was very easy. Just you need to solve the equation in the given pattern. The next question is question number 20. Question number 20 says if A, B, C are in AP, which means 2B is equal to A plus C. The first hint is this: B, C, D are in GP, that is C square is equal to BD, and 1 by C, 1 by D, 1 by E are in AP. So it means 2 times of second term is equal to 1 by C plus 1 by E. So these three things are given and you need to prove that A, C, E are in GP. So simply you need to show that C square is equal to A into E. Yeah, this you need to prove. So this is the question. Given things of question. Now what we have to do? We have to solve it. So from equation 1, 2 and 3 you have to eliminate A, B and D. Since we have to prove in terms of C, A and E, isn't it? So it should be yeah, C, A and E. So we have to terminate all the other values like B and D. So what we can do here, it is 2 by D, and do we know the value of D? Wait, 2 by D is equal to 1 by C plus 1 by, okay, so 2 by D. So the value of D should be, what should be the value of D? If I'll write from equation 2, the value of D is C square by B. But we want the value of the variable C, A and E only, okay? So we don't need B. So we have to eliminate B again. So it is 2B by C square. Now the value of 2B is A plus C. So I'll write A plus C by C square. This is from 1 and this is from 2, okay? Mind it. So it is C plus E by CE. We can cancel out 1C. So it will give A by C plus C by C is equal to C by E plus E by E. This is 1, this is again 1. So A by C plus 1, C by E plus 1. It is nothing but A by C is equal to C by E. So it is C square is equal to AE. Proved. So what we have to do here, we have to prove C square equal to AE. So we have to eliminate B and D. So from in this equation, what we don't need D. So I have placed the value of D as C square by B. But again, I don't need the value of B, the variable B. So what I have done, I have taken the value of B from here and placed it. So the equation comes in A, C and E. Okay, moving on to next question. Next question is question number 21. Question number 21 has two parts. First one is find the sum of the following series up to n terms. If you remember that I have given you a pattern for solving such type of question, I am doing it again. So sum is equal to 5 plus 55 plus 555, and it goes on like this. Now if I'll take 5 common, it is 1 plus 11 plus 111, and it goes on like this. Okay, now in the next step what we have to do, we have to divide and multiply by 9. So it is by 9 into 9, so it is 9 plus 99 plus 999, and it goes on like this. So it is 5 by 9. 9 can be written as 10 minus 1. 99 can be written as 10 square minus 1. And it can be written as 10 cube minus 1. And it goes on till n terms. Now if I'll separate 10, 10 square, 10 cube, and all the 1 with negative sign in another bracket, this is nothing but sum of n terms of GP. So it is A, what is R here? 10, Rn minus 1 by R minus 1, that is 10 minus 1, so it is 9. Again, if I'll add 1 n times, so it is n only. Okay, so in the next step what we can do, 5 by 9, 10 to the power n plus 1 minus 10 minus 9n by 9. Can we write it here? 9 into 9. So it is nothing but 5 by 81, and here we have 10 to the power n plus 1 minus 9n minus 10. Okay, so this is question number 1 of 21. Clear? Now this question is similar, but it is a decimal question. So let's see what we can do here. So it is 0.6 plus 0.66 plus 0.666 plus like this. Now if I'll take 6 common, it is 0.1 plus 0.11 plus 0.111, and it goes on like this. Okay, so I can write it 1 by 10 plus 11 by 100. Okay, so here we can write 11 by 100, 111 by 100, or we can write it 6 by 9 into 0.9 plus 0.99 plus 0.999, and it goes on like this. Skip this. Okay, so now we have 6 by 9, and here we have 1 minus 1 by 10, and then we have 1 minus 1 by 10 square. Similarly, we have 1 minus 1 by 10 cube, and it goes on like this, isn't it? Okay, so now we have 6 by 9. Now we have 6 by 9 and 1 plus 1 plus 1, and in the next bracket we have 1 by 10, 1 by 10 square, and it goes on like this. Okay, so it is 6 by 9. If I'll add 1 n times, so I have n minus, this is sum of GP, so it is A 1 minus Rn by 1 minus R. That's it. Now you can simplify this. This will give you the answer. Okay, so this was question number 2 of 21. Okay, so we can solve this equation like this only, this also, but I am doing in this way. So the next question is question number 22. Question number 22 is find the 20th term of the series. The series is 2 into 4 plus, so the question says you have to find 20th term, so you don't need to find the sum. We always used to find the sum, but in this question they always only asking for 20th term, so you are not required to go for SN. So it is 2 into 4, 4 into 6 plus 6 into 8, and it goes on like this. Now we have 2, 4, 6. So what we have, 2, 4, 6 is a plus n minus 1 d. So it is 2 plus 2n minus 2. So we have 2n. Nth term is 2n. And what for 4, 6, 8? Second group, 4, 6, 8 is 4 plus n minus 1 d is 2 here. So 4 plus 2n minus 2. So I have 2n plus 2. So it is 2n plus 2. So if I need to find the 20th term, then I have to put the value of n as 20. So it is 2 into 20, and then we have 2 into 20 plus 2. So it is 40, and here it is 42. 1680 is the answer. Okay. So this is question number 22. This was very easy. So that's it for the session. We will discuss next question, remaining question in the next video. Okay. Till then, bye bye. Take care. Okay.